I've done loads of videos on differentiating and integrating the inverse cosine, tan, and sine functions, whereas in this situation we have the inverses, but it's okay. I've done lots of videos on differentiating and integrating the inverse of the cosine, sine, and tan functions, but in this situation, it's stuck in a fraction. So we're first going to recognize that fx equals ux over vx, and we're going to use the quotient rule, which is this differentiated once as vu dash minus uv dash over v squared, where the dashes denote when the function or the part of the function has been differentiated once. So we're going to let u equal the numerator, so it's going to be 2 cos minus 1 3x, and then du dx is going to be 2 dot d over dx cos to the minus 1 3x. Oh, can't really fit that in, but that's just a bracket. So we know that this differentiated, there should be an equals there. This differentiated is going to be 2 multiplied by minus 3 over 1 minus 3x all squared. You want to know how we got from that to that? I've got a whole video on differentiating just the inverse of cos x. We can now simplify this, so obviously you multiply the 2 in, and so you're going to get minus 6 over the square root. Oh, I missed the square root here. Yeah, I missed the square root. The square root of 1 minus 9x squared. I've just squared this in. We now know that v is x squared, so therefore dv dx is pretty simple. That's 2x. So maybe I can fit this all in here. We can then substitute each of these values into this. So we're going to get x squared dot minus 6 all over the square root of 1 minus 9x squared minus 2 cos minus 1. I'm going to put a line here to the 3x multiplied by 2x all over x to the 4. That would be fine. You can simplify this out. You can multiply the denominators together. You get x4. And you can actually break this down a little bit. So you would get x to the power 4 multiplied by the square root of 1 minus 9x squared as the denominator. And you'd have minus 6x squared on the top, minus, and then it would be 4x cos to the inverse 3x divided by x to the 4, because we've just simplified that out. But that's it. Pretty simple.